Hello, this is a video to help you with homework in section 5.1, and I go through each of the homework problems. So if there's a particular problem that you're looking for, just scroll through in order until you find what you need. So the first problem that shows up and the first two problems that show up are very similar, and it makes sure you really understand the definition of ratio and proportion. So I'm going to go through every one of these questions and address whether that's true or false. When you do the problem in the homework, you drag the true or false, but I'm not really in the homework right now. I'm in a PowerPoint presentation, so I'm just going to put T or F for true and false. Number one, the quotient of two quantities is called a ratio. That is true. So quotient, usually written as a fraction. Doesn't have to be written as a fraction though, but that is a ratio. I don't have my pen set up to draw. Let's try that again. So this one is true. The ratio 7/5 means the same as the ratio 5/7, and that's not true. You could read the first one is the ratio of 7 to 5. The second one is the ratio of 5 to 7, and we know 7/5 is not the same fraction as 5/7, so this one is certainly false. The ratio of 7.2 or 7 2/10 to 8.1 or 8 1/10 is in simplest form, and we know that's not true because decimals do not belong in a fraction in simplified form. So you can't leave decimals in a simplified fraction form, so that is false. And it's because of the decimals in there. The ratio of 10 feet to 30 feet is in simplest form, and that's not true. That is false, but if I were to put that in simplest form, first thing, feet over feet cancels, and 10/3 reduces to 1/3, that would actually be simplest form for that ratio. The ratio 9/10 is in simplest form. That is true. The ratio of 2 to 5 equals 5 over 2. Remember, we talked just a minute ago about the first number listed is the numerator, and the second number listed is the denominator. That is always true, and that is not equal to 5/2, so that is a false statement. The ratio 30:41, you could read that as 30 to 41. The 30, remember, goes in the numerator because it's first. The 41 goes in the denominator because it's second in the ratio, and that is correct. 30 to 41 in fractional notation, that is true. The ratio of 15 to 45 is 3 over 1. Now remember, again, the 15 goes in the numerator. The 45 goes in the denominator. When I reduce this to simplest form by dividing each of these by 15, because the greatest common factor is 15, that actually reduces to 1/3, not 3 over 1. Remember, 1/3 and 3 over 1 are not the same. So that is a false, a false statement. All right, let's try the next problem. So, this one, the first time I looked at it, I found it a little bit intimidating. And I know these answers, so I get it if you're struggling with this one. A rate with a denominator of 1 is actually called a unit. Okay? So again, this is another drag and drop situation, but I'm not really in the homework. I just copied and pasted the homework problem. So that one's unit. I was even wondering, but some choices may be used more than once. There it is. For some reason, the first time I did this problem, I did not see this statement, and I was curious if we could reuse or not, or if we would use, one each, and I had leftovers, so there you go. You could possibly reuse. A blank is the quotient of two quantities. That one is ratio. So we've used unit. I'm going to check it, but remember we could reuse them. Now we're going to use ratio. The word per translates to division, actually. I'm looking for division. Yes, that's it. So the word per, when you see that, think division. To write a rate as a unit, divide the numerator of the rate by the denominator. So the numerator by the denominator. Okay. 4.2 over 8.4 equals 1/2. Whenever you see a fraction equal to another fraction, that is what we define as a proportion. All right, while 7/8 is just a fraction, that would be deemed a ratio. So a ratio equal to another ratio or a fraction equal to another fraction is actually called a proportion. Okay, A over B equals C over D. Notice what's happening here. They're saying A times D, it's crossing this way, is equal to B times C, it's crossing this way. That is a cross product. Okay, and a proportion if cross products are equal. Okay, so for instance, if you look at this proportion, 4.2 over 8.4 is equal to 1 over 2. If you cross this way, 4.2 times 2, I'm going to write it this way, equals, and then you cross this way, 8.4 times 1. Notice they are equal. If that is true, then you're dealing with a true proportion. Okay, and if proportion of the cross products are not equal, the proportion is false. For instance, if I give you 2/8 is equal to 1/3, that is set up as a proportion. A fraction equals to a fraction, but if we calculate the cross product, 2 times 3 is 6, equals 8 times 1 is 8. Notice 6 does not equal to 8. That means that is not a true proportion. It is false. All right, notice problem 3 says write the ratio using fractional notation. So remember 5 to 2, the first number always goes in the numerator. So we have 5 to 2 over 2. And notice this one said do not simplify. Okay, now this one actually does not simplify anyway. You're not really trying to write ratios as mixed numbers typically, so that's not what they mean by simplify. They mean if there is a common factor for both the numerator and the denominator, we would have to divide by that common factor to reduce it. But this one said do not simplify anyway, so we're done with that one. All right, now this one gets a little more interesting. It's the same problem, but of course more complicated numbers to deal with. We have mixed numbers. So this is 9 and 1/3, 2. Remember, so the first number always goes in the numerator, to 3 and 1/2. Okay, now I want to make sure you understand when you're dealing with mixed numbers, it's often much easier to change them to improper fractions to do work, especially when you're multiplying and dividing. Adding and subtracting either way, but this is division, clearly, because it is a ratio. All right, so the first thing I'm going to do is change my mixed number 9 and 1/3 to an improper fraction. Remember, to do that, you do 9 times 3 is 27, plus 1 is 28, and you put that over the original denominator. So that's 28/3. I'm going to do the same steps here. 3 times 2 is 6, plus 1 more is 7, and you put that over the original denominator, which is 2. All right. Remember, the next step when you're dividing fractions, this is your 28/3 really divided by 7/2. If you need to see that written down, it's 28/3 divided by 7/2. That means exactly the same thing as what we have written right here. But you know that you flip your divisor. In other words, multiply by the reciprocal. So whether it's written down here or after the division sign, you must flip and multiply. So this is 28/3 times 2/7. Now, the way to multiply fractions, remember, is numerator times numerator, so 28 times 2, divided by denominator times denominator, 3 times 7. But we are allowed, this is called cross-canceling. It's not the same thing as cross-product. So these two numbers, 28 and 7, have common factors. They both divide by 7. So that's what I'm going to do. 28 divided by 7 leaves me 4, while 7 divided by 7 leaves me 1. And you can do that as long as you're dealing with a numerator and denominator. It doesn't matter if they're directly over each other or if they are in separate fractions. You can cross-cancel before you multiply, and that just makes your work a little bit easier. Okay, so now I'm going to do 4 times 2 is 8, over 3 times 1 is 3, and this is my reduced ratio. But you know what? I just read the directions. And that's my problem sometimes. I don't read the directions. It said do not simplify. So actually, this is what they want us to type in because they did not want us to simplify. I assume that's what they want us to type in right there. But if we were asked to simplify, this would be what we type in. So if I would have done this on the computer, I would have missed it because I simplified it. So don't be like me and read the directions. Okay, so 9 1/3 over 3 1/2. All right, next problem. Write the ratio as a ratio of whole numbers using fractional notation, so 7 to 35. Notice it says type the ratio as a simplified fraction. So this time it does say to simplify. So if you're struggling with these problems, maybe more reading the directions, which again I'm notoriously bad at sometimes. So when you do this, the ratio of 7 to 35 is 7 over 35. Now we have a greatest common factor here, right? 7 divides by 7 and 35 is also a multiple of 7 or divides by 7. So 7 divided by 7 is 1. 35 divided by 7 is 5. And that gives me the simplified ratio of 1/5. Okay, write the ratio. I'm doing number 6 now. Write the ratio as a ratio of whole numbers using fractional notation. So just like the same last directions, but this time we have some units. All right, so let's talk about this. Again, the first value listed in the ratio is always the numerator, 20 hours. The second value listed is always the denominator, 35 hours. Now let's read directions. It says type the ratio as a simplified fraction. Well, first I want you to realize when you're dealing with units, if they are the same unit, both numerator and denominator, that cancels just like a greatest common factor. So hours cancels with hours, and then you're left with the fraction 20 over 35. Both of those are divisible by 5, so let's do that. So I'm going to divide 20 by 5. I'm going to divide 35 by 5. Usually I've just been doing this in my head, but feel free to write that down to remind yourself of what you're doing. You know, 20 divided by 5 is equal to 4. 35 divided by 5 is equal to 7. This is a reduced or simplified fraction. So it's not really reduced because it's not smaller, right? It is a simplified fraction. Now, make sure you check your simplified fraction to make sure there's not a greatest common factor again. You know, what if we picked 5 because they're both divisible by 5, yet there was a number that was larger than that they were both divisible by? Not in this case, but check it. And 4/7 does not have another greatest common factor, therefore we are finished with that one. All right, here we go. Problem 7. Write the ratio. Write the ratio as a ratio of whole numbers using fractional notation. So here we go again. We have units again. So 33 days over 24 days. Again, always remember that the first value listed is your numerator. The second value listed is your denominator. And then when you have common units, then they cancel out. That leaves you with the fraction 33 over 24. But 33 and 24 also have a greatest common factor of 3. So 33 divided by 3 and 24 divided by 3. We need to do that to get our fraction in simple form. So 33 divided by 3 is 11. 24 divided by 3 is 8. And 11/8. Make sure again there's not another greatest common factor, and there's not. That means we have completed the problem. Let's try 8. Very similar, same directions. So I've got 12 inches divided by, so remember the first value listed is your numerator. The second value listed is your denominator, 16 inches. Inches cancels. That's exactly the same unit. It's like dividing 1 inch by 1 inch. And that just cancels out, or it gives you 1 is the best way to think about it. I'm left with 12 over 16. But they also have a greatest common factor of, you may see it, it's 4. 12 is a multiple of 4. 16 is a multiple of 4. And that would give you, when you do 12 divided by 4, it gives you 3. 16 divided by 4 gives you 4. I'm going to do a quick check again. 3 and 4 have no common factors. Now, this is an example of what I was talking about. If we said 12 over 16 and we divided each of those by 2, because yes, they are divisible by 2, and then I do 12 over 2 is 6, and 16 over 2 divided by 2 is 8. Notice that I'm not finished with this one because they also both divide by 2 again. So if you don't get the simplest form the first time you divide each of them by a common factor, then you must keep going to get the correct answer. So that's why the greatest common factor, 4 in this case, is the fastest route to take, but not the only route to take. All right, now everybody's favorite type of problem, word problems. And you see these a lot in ratios. It's going to be okay. So find the ratio of the longest side to the perimeter of the right triangle. So let's make sure we understand what they're saying. So they're saying the longest side, that's going to go on top. 2, which means we're talking denominator now, the perimeter. And if you have to write it like that to translate your word problem, please do. Okay, so when I look at my triangle, what is the longest side? So it lists all 3 lengths, which is very helpful. 29 feet is the longest side. So notice I'm going to put the units there too. That's 29 feet. Now perimeter, what does perimeter mean? And you've probably dealt with this before. I hope so. But if not, anytime you see the perimeter of a figure, that means the distance around the figure. So no matter what the shape of the figure is, don't you worry about memorizing a formula for this. You add all the lengths together, no matter what the shape is. So I've got 29 feet. I need to add to 21 feet that I need to add to 20 feet. So let's write that down. 29 feet, I'm just going to use FT for feet, plus 21 feet, plus 20 feet. Now before we can do any kind of simplifying, I'm going to have to add that together to get the true perimeter. So I have 29 feet still in the numerator, and the perimeter is 29 plus 21, which is going to give me 50, right? And then 50 plus 20 is 70 feet. Now, if I want to be really, really careful, I'm not going to do that in my head. 29 plus 21 plus 20 on a basic calculator does give me 70 feet, okay? So, just to be very careful about it, I checked it with a calculator. Now, remember the next step is the same unit, feet and feet, they cancel out. So feet over feet cancels, and I'm left with 29 over 70. Notice my directions, which remember I read after I do a problem apparently. Type the ratio as a simplified fraction. Now here's the question. Do 29 and 70 have any common factors? Can I divide 29 by a number and 70 by the same number to reduce this fraction or simplify this fraction? And the fact is I can't. 29 is a prime number, okay? And 29 does not go into 70. So when I say 29 is a prime number, that means the only divisors of 29 are 1 and 29. And 1 will not simplify a fraction, right? If I divide each of these by 1, I'm still 29 over 70. But I have to make sure that 29 doesn't divide into 70 evenly, and it doesn't, okay? So this is our fraction in simplified form, which I often say lowest terms, but simplified form is what the homework is using. Okay, next problem. In a recent year, a production company releases 965 films. A total of 75 of the films released were digital 3D films. Find the ratio of digital releases to total releases. So again, if you find these word problems overwhelming, I highly recommend making your pen work to start with. There we go. I highly recommend writing words for your ratio. So it says find the ratio of digital releases. Remember the first value goes on the top. So digital releases. And then you have 2, which means the next thing is going to be a denominator, total releases. So don't let this overwhelm you. Make sure you see, find the ratio of. So digital releases is on top, total releases on the bottom. Then dig through your problem to see if you have that information. Remember the last problem we did, with the triangle and the perimeter, we didn't have all the information. We had all we needed, but we didn't have perimeter. We had to calculate that. So let's see what we have here. So digital releases, okay, and it says a total of 75 of the films released were digital 3D films. So I assume that's what they mean by digital releases. So 75, okay, over, and if you think about this in terms of units, it's 75 movies, okay, or films. They called it films, so let's do that. So 75 films over total releases. That information was given. A production company released 965 films, so 965 films. Now, once again, films cancels out, so I'm charged with reducing or simplifying the fraction 975 over 965. Now, let's think about this, right? What number do we clearly see divides both 75 and 965? And we know that both of those divide by 5. Why do I know? Because any number that has the ones place with a 5 or a 0 is divisible by 5. So let's do that. Is that the greatest common factor? Who knows? But it's going to be the fastest way to get this job done. So 75 divided by 5 gives me 15. And 965 divided by 5 gives me 193. Now, is that a simplified fraction? And another way we call that is lowest terms. Well, I don't know without playing around. Now, I do know that the factors of 15, all there are 3, 5, and 15. So I need to see if 193 divides by 3 or 5 or 15, right? Now, I know it's not going to divide by 5, right, because 193 ends in a 3. And numbers divisible by 5 always end in a 0 or 5, okay? Well, it's going to be the same case for 15. It's not going to divide into 193 because it's also divisible by 5, so the same story applies there. All right, so let's see if it divides by 3. And you could do that long division, you could do it with a basic calculator, and it doesn't. When I divide it with a basic calculator, I get 64.333, or 64 1/3. So that means that this does not divide by 3. Therefore, we are completely simplified. The town has 6 flower shops. Their 1-year sales figures are compared in the chart. Find the ratio of sales at Corolla and Sons to those at Radio Flowers. So once again, don't let this overwhelm you. Notice that it gives you a ratio. Let's write that in words. Okay, so find the ratio of sales at Corolla and Sons. So that's listed first. So Corolla and Sons to those at Radio Flowers. So to Radio Flowers. All right, so Corolla and Sons, let's find that one. That's 130,000. Let's write it exactly the way it says it. 130,000 to Radio Flowers. There it is right there. That's 390,000. Okay, the thousands cancel. And then we're left with the fraction 130 divided by 390. And then, do they have any common factors? Well, the first thing I want you to realize is that when you have a fraction and both numbers end in 0, you can just cancel the zeros. Why can you do that? You're really dividing these both by 10, okay? And that's going to give you 13 over 39. Well, turns out 13 is a prime number, like the last number problem we talked about. The only thing that divides 13 is 1 and 13. 39, though, does divide by 13. So we could divide both of those by 13, and that's going to give me 1 over 3. Now, I noticed right off the bat, it's just because I do math, and so I recognize this here. It's not the answer. This is the answer. But 390 divides by 130. So I could have done that right off the bat and got 1/3. But this is a prime example to me of when you reduce, sometimes you don't have to find the greatest common factor, that you could do it in a couple of steps and it just makes your life easier. Okay, so 1/3 final answer there. All right, so number 12, write the ratio as a fraction in simplest form. So we have 4 shrubs every 8 feet. Now notice the word 2 is missing here, but the order is the same. So you could think about it as 4 shrubs, 2 every 8 feet. It's an implied 2 in there. So we put 4 shrubs, 2 every 8 feet. Okay, notice this says type the ratio in simplest form. Okay, so 4/8 reduces, but are shrubs and feet the same unit of measurement? And they're not. And so it's going to stay shrubs over feet. Now we do know that 4 is divisible by 4, and so is 8. So I'm going to divide each of those values by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So it's going to be 1 to 2, or 1/2. And because the units do not cancel, it stays in ratio form, shrubs to feet. Okay, now this is a click down menu and you're going to see either shrubs to feet or feet over shrubs. You have to keep it in the order that it's in, and that's what you'll type in. Okay, number 13, write the ratio as a fraction in simplest form. 9 phone lines for 6 employees. So it's 9 phone lines to 6 employees. Now, once again, phone lines and employees, those are not the same unit of measurement at all, so those will not cancel. That part of the ratio stays, but 9/6 does reduce. They both divide by 3. Okay, so 9 divided by 3 gives me 3, and 6 divided by 3 gives me 2, and you still keep phone lines, excuse my writing, per employees. And notice they don't have that as a selection like the last problem. So it is phone lines per employees, and this is going to be 3/2. All right, problem 14 and 15. And then I'm going to shut this video down and do a part 2 because I don't want the video to be so long. So write the rate as a simplified fraction, 65 fence panels. Let's try this. Oh, there we go, 65 fence panels. 2. Notice it says 4, but 2, 4, 1274, or 1,274 feet. Now, are feet and fence panels measuring the same unit? They are not. So those do not cancel. So when we look what goes in the drop-down menu here, it's going to be fence panels per feet. Okay. Now, the 65 over 1,274, do they have any common factors? Well, those are big numbers to deal with, right? Now first, let's address the most obvious, is that 5 does divide into 65. But 5 does not divide into 1,274 because it doesn't end in a 0 or 5. So I'm not going to divide them both by 5. Okay? And then the last one before we change videos, write the rate as a unit rate. Now, what does that mean? 300. Let's write it. First of all, 345 calories and 3 ounces. So again, you can think about that as 345 calories in a 3 ounce serving. So 345 calories and 3 ounces. Now remember, a unit rate means the denominator is equal to 1. So they're implying that 345 divides by 3, or else we couldn't get the denominator equal to 1. And 345 does divide by 3. You could check this by adding, the divisibility test for 3 is you could add all the digits together. And if the total or the sum is divisible by 3, then this is. So 3 plus 4 is 7. 7 plus 5 is 12. 12 is a number that's divisible by 3, so that means 345 is divisible by 3. And then you can use your basic calculator and divide 345 by 3, and I get 115. So that's 115. Now remember, what we've really done is we've divided by 3 here and divided by 3 here, and that's over 1, and that's calories per ounce. Remember, the word per really just means the fraction bar or divide. Now when you have a fraction with 1 in the denominator, you really don't have to write the 1. So it's 115 calories per ounce. And over here on the drop down, it should give you the option of calories per ounce, and then 115 goes in that spot. So come back for part 2, and that'll be problem 16 through 28. I hope you found this helpful.